All right. First, take any questions you have from that test I just gave back to you. Let's see. I think I don't have a couple of tests. One human is not here. Jameson, do you have your test for me? That would be grand. Sure.
Oh no, it doesn't in here. This is not good.
What should we do? It says factor completely. And that squiggle is a 4. We should. The first is the square root of the first, and the second slot is the square root of the second. What's the square root of x to the fourth?
X squared.
X squared. And then what's the square root of 16? 4. What do the signs need to be? What now? We can, because we've got another difference of squares. So what's the square root of x squared? And what's the square root of 4? 2. And then plus or minus. I will be right back. I'll check on something. Don't say profanities.
Why are you pointing at me?
Because you were there.
Oh yeah? What's the story behind that?
I was just sitting here. It's what he's saying.
You said you were there.
I said I'm sitting right here.
No, I think he was insinuating something about your dark past.
I don't have a dark past.
Says you. I believe you.
Okay. As long as I believe in myself. I just had to, okay? It was necessary.
This one is not just for
I had to say something stupid.
Back the picture. I wouldn't quantify that as stupid. It's just optimistic.
Yeah. I just had to.
Look at that mistake I made.
The opportunity was there, so.
Why didn't you show up to that one for girls? Just for fun?
Yeah.
It's just those little.
I was told that that was the day that cast to go see it. Yeah, I was going.
Oh.
Or the crew, I mean.
Are you gonna come to the dress rehearsal?
Of course.
Yeah.
Of course I'm gonna.
Sorry.
I just said be.
I didn't put it in the code.
I just can't.
To dress rehearsal meets?
No, I'm just going to go up.
No, that's fair. I think it's great that you want to come watch.
I want to see how it's going.
That's fair. And I know to come on Wednesday because that's my dress rehearsal.
And also, London was telling me that I should also go see hers too.
No, absolutely. That's what I'm
Yeah.
going to see.
I want to see how both.
Let's see it.
Both
Ooh,
pose.
you're gonna, yeah, both pose.
Battle of the pose.
What others? Sure. 5, I did have multiple people miss. Oh. Polynomial. State the degree leading coefficient. If it's not a polynomial, say not a polynomial. So, not a polynomial. Why not? It's negative exponent. This would be 4 over x. So not a polynomial. Done. Okay. That's how it's done, done, done.
My sisters just got done with that. Like just. It's been months of non-stop.
I could see that being too much. Although I did think it was pretty great. Any other test questions? Okay, let's do today. All right, we're on 6-2. What are we doing? Wow. You're trying to fight me right now? That's crazy. 6-4 and 6-5. That means we got tests coming up. I don't know. I have to look at Google Classroom. I don't carry all that around in my head.
No, after 6-5, we have another lesson on 6-5 after 6-4.
That was due today.
Wait, I thought there was one more, wasn't there? Yeah.
Yeah, we definitely cover 6-6.
Yeah, it'll be the beginning of next week, right?
I don't know. I'd have to look at Google Classroom. We've been over this. Just look at Google Classroom and it'll tell you when the test is. It pops up like 2 weeks ahead of time. It says the unit blah, 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 test is scheduled for the blankety blank, 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 blank. You just flip and read. Anyway, number 12, plus or minus 11, x squared, y to the 8th. 14 plus or minus 7x squared. Excuse me. 16 is negative 9, a to the 8th, b to the 10th, c to the 6th. 18, x plus 15, quantity squared. 20, a squared plus 4a, quantity to the 6th. 22, d to the 4th, x to the 6th. Excuse me. 24, negative, absolute value, 2x plus 1, quantity cubed. Negative, quantity, y minus 9, quantity cubed. 28, the absolute value of a cubed. 30, 3 times the absolute value of x to the 4th. 32, quantity y cubed plus 5, quantity to the 6th. 34, x squared times the absolute value of y. Is that how far we went on this? 46. That's crazy. Number 36 is 3. 38, 9.592. 40, 0.656. 42, 5.518. 44, 20.733. 46, 1,006.2. 8,000, 12.4. 64,000, 24.8. 46b is something like as r doubles, the volume increases by a factor of 2 cubed or 8. You said how far did we go? 46. Well, y'all figure out what questions you have. I'm going to get some water because I need water. You You can't be doing a high fiber diet without drinking water. Bad idea. It is, in fact, what it is. What numbers do you need?
46A.
46A. The radius of a sphere with volume V can be found with the formula. This is just the volume formula solved for R, right? But R equals the cube root of 3V over 4 pi. Determine the radius for volumes 1,000, 8,000, and 64,000. What do we do? Sounds great. Let's do it. What's 3 times 1,000? What now? Divide by 4 pi. Now, if you mess these up, quite possibly what you put in your calculator was this. Probably. This is a problem. Because what this tells your calculator to do is 3,000 divided by 4 times pi. Which, to write this in a more like algebra way, this will even more light bulb what's happened. This, what you did was 3,000 times pi over 4. So on the calculator, you may have accidentally floated that pi up to the top. So there's 2 ways to fix it. One is this is kind of always a good habit potentially, but one is to go like that, right? And then you divide it by everything. Another way you can punch it in the calculator to get the same answer is 3,000 divided by 4 divided by pi. That would also get you the right answer. But it's very possible that if you mess this one up, it was a calculator mistake. And then whatever that number is, you just do the cube root of it and push enter. Don't forget that somewhere on your calculator is this. It will be like a second or a shift answer or something, which is a variable that always holds the previous answer. So like when you get something point blah 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 and you're trying to find the cube root of it, if you just hit cube root second answer, then it'll look cube root of whatever that is. It keeps you exact, right? And then you do that for all the 3 numbers, and Bob's your uncle. Moving on. What other questions from this lesson do we have? We could do 12. So what?
When are you supposed to put actual value on it?
We'll do one of those in a minute. I'll show you. The simple answer is if you start with an even root and end up with an odd power. I was answering your question. That's the simple answer. But we'll do one and we'll show you in a minute. Number 12. I've always thought that these are easier to think through in your brain once you have the tool that comes in lesson 6. I have at various times teaching math just kind of skipped to that idea because I think it makes easier to think about, but we won't do that today. Okay, we got the square root of product. What do we do with that? Yeah, square root all the bits, right? So this is the square root of 120. What's the square root of 121, which is what? 11. That's what you meant, right? Yeah, totally. Okay, and then the square root of x to the fourth. So thinking through it in this lesson, that would be like the square root of x squared times the square root of x squared, right? That's easy peasy, right? What's the square root of x squared? X. I'm going to make a note of something, that even though I'm doing what kind of a lot of people do and doing like a part of the problem, I am not writing a little bit over here and then a little bit over there and a little bit over there and a little bit over there and then circling the answer in some weird random place, or half the time not even circling the answer and hoping that I can find what in the world your answer is, or adding some stupid underline which nobody can even find. I am kind of doing it the way a lot of people do it and do a little piece at a time, but I'm still keeping it all organized just like normal, right? So the square root of x squared is x. So we've got x times x. What's x times x? X squared. Easy money, right? So the square root of x to the fourth is x squared, which we can use that idea to get us this one quicker, right? It's going to be the square root of y to the fourth times the square root of y to the fourth, right? Because 4 times 4 is 16, right? We just figured out that if you square root a fourth, you end up with a squared. So we've got y squared times y squared. What's y squared times y squared? Y to the fourth. Which in lesson 6, we're going to either remember or learn that square roots are rational exponents. So this would be square root of x to the 4 over 2 times y to the 16 over 2. What is what's wrong with this?
Are you supposed to take it and like do parentheses 2 to the power?
Oh, this would be,
Is it y to the 8?
it is y to the 8. This would be y. What did we do wrong?
Or are you supposed to put that the parentheses inside the thing to where you put to a power so that it cancels out?
Oh yeah, that is what we learned. I was going even further back. Sorry. Let me do it the way that you've actually been taught. This is even easier. But try again. How about the square root of x squared squared? And the square root of y to the fourth, no, to the 8th squared, because 8 times 2 is 16, right? Square, what happens to square and square root? They cancel out. So back to what I was saying. In lesson 6, learn that square root is 8 divided by 2 exponent. 4 divided by 2 is 2. 16 divided by 2 is 8. So once we learn it that way, I think it's a lot easier to think about, because division is super simple compared to like, okay, how do I extrapolate this out? Okay. What other ones from this lesson? With the Q30. 30 has got lots of good things happening that are useful to learn and relearn and highlight some ideas of. So for 30, we have the fourth root of 81 times x plus 4 to the fourth. Okay, so what do we need to do? We should split into the fourth root of 81 times the fourth root of x plus 4 to the fourth. You are correct. What's the fourth root of 81? 3. What's the fourth root of x plus 4 to the fourth? It's just x plus 4. Now, it's got to be this in parentheses. Why is that true? It's true because we started and we were doing a fourth root, an even root, and we ended up with an odd exponent. 1 is odd. If this was a 3, this would also be here, or 5, or 7, etc. And that is because when you evaluate this with an odd root, it can come out negative. And we cannot take the even root of a negative and stay on the real plane. We jump into 2 dimensions and we end up in the complex plane. Ain't there? And we only got one variable to work with. Okay, so if you start with an even power and end up with an even root and end up with an odd power, you have to put that in absolute value.
So also, whenever you do like the parentheses,
Mm-hmm.
and then you do like 6 to the 3 to cancel out the power of 3. In
Right.
the 6, do you distribute that like power to all the others and then solve it like that? Or you
So like if your answer came out to be y cubed plus 5 to the 6th, no, you leave it like that. And the 6th, this is very important. I'm glad you asked it the way you asked it, because this would not just distribute because of the plus. Because this would be y cubed plus 5 times y cubed plus 5 times y cubed plus 5 6 times. And then you'd have to distribute and distribute and distribute and distribute. And so it's going to end up with a bunch of extra terms in the middle. If you just distribute it, you'll get the very first one and the very last one, but you won't get all of the other junk in the middle. So you would just leave it like this. What other questions from this lesson do we have? 26. This is a good counterexample. I don't know whether you meant to do that or not, but this is a good counterexample. The cube root of negative y minus 9 to the 9th. And we're supposed to simplify, so what should we do? No, we can't because of the 9. No. 3 is odd. The I would only show up if it was even.
You divide the exponent by 3.
Not yet. But yeah, you're going to. In a minute. I gotta split up this product. What's the cube root of negative 1? Negative 1. Because negative 1 times negative 1 times negative 1 is negative 1. True enough. Root of y minus 9 cubed, because power to power multiply, 3 times 3 is 9, right? What happens to cube and cube root? Cancels out one of them. Now, so there's a couple puzzle pieces in here that are potential for making mistake or confusion or whatever else. First of all, this negative stays because it's an odd power. Also, there is no absolute value around here, and that's correct. That's not wrong, even though we ended up with an odd power. But we started with an odd root, so that's fine. Just as we demonstrated here, you can take the odd root, the cube root, fifth root, seventh root, etc., of a negative and still have a negative. So this is totally fine. Let's look at 6-5, shall we? Do some conjugate shenanigans. Those of you who are going on to pre-cal, or if you're doing like a legit business math, which I'd recommend doing pre-cal with me instead of that if I were you, and save the legit business math till college, because that's a hard class, and if you take pre-cal, it'll be easier. Not necessarily easy, but easier. Anyway, all that random nonsense aside, what numbers did we do? 2 through 36 evens. Number 2, 12x cubed y cubed times the square root of xy. Excuse me. Number 4, the fourth root of 10x cubed. Excuse me. The fourth root of 10x y cubed all over 2y. 6, 100a to the fourth. 8, 3x times the absolute value of y. Number 10, 8 times the square root of 10 plus 6 times the square root of 7 minus 10 times the square root of 2. 12, 184. 12 would be a good example of, and actually you might get a weird rounded answer anyway, but 12 would be a good answer of example of a problem, also 10 for that matter, would be a good example of a problem that if you just like wrote the answer because you shoved it in your calculator, it would be wrong. You must show all the things that you know how to actually do it. Number 14 is negative 40 minus 8 times the square root of 6 all over 19. Number 16, 27 minus 10 times the square root of 3 all over 13. 18 is invisible. There it is. 6a to the fourth b squared times the square root of 2b. 20 is 2a to the eighth b to the fourth times the square root of 6c. 22 is a squared times the square root of 5ab all over b to the seventh. 24 is the cube root of 150 times x squared times y squared all over 5y. 26 is 120y times the square root of 2z. 28 is 144ab squared times the square root of 2. 30 is 9 times the square root of 10 plus 8 times the square root of 5 plus 9 times the square root of 2. 32. 8 times the square root of 7 minus 72 times the square root of 10 plus 2 times the square root of 11. 34. 16 plus 2 times the square root of 3 plus 2 times the square root of 6 feet. 36. 8 plus 32 times the square root of 5, all of that times pi inches squared. Did we go through 44 or 36? 36. What questions do you have? We could do 22. The square root of 5a to the fifth over the square root of b to the 13th. So, what should we do?
Should we split b into 12 and b?
Sounds good to begin with. So this equals the square root of 12. No. Square root of b You can even go ahead and do b to the 6th squared, right? That's 12 times the square root of b. All right. What about the numerator?
We pull out the a to be a squared times 5 times the square root of 5a.
Yes, yes. A squared squared, because 2 times 2 is 4, times the square root of 5a, because 1 plus 4 is 5. True enough. Now what?
Now we cancel the square roots.
Cancel the square roots. So we've got a squared times the square root of 5a over b to the 6th times the square root of b. No absolute value needed. We had started even, ended even. So far, so bueno. We do. We can't be having those square roots in the denominator. We don't like that. It's ugly. Square root of b over the square root of b. So we've got a squared times the square root of 5ab over b to the 6th. Okay? What else? Sure.
Yeah, that's the one that both down the area. On this one, it has the y term and it changes to y4 because of the extra b.
Wouldn't it be b? What are you saying? Oh, yes, yes, it would be. My bad. Yeah, because we got that times square root of b squared times b, which would make it to the 7th. Yes, my bad. That's correct. Sometimes somebody says something that is annoying, even offensive. Did you know that if you're offended, it's your fault? Always. That doesn't mean that somebody didn't do something that was offensive. That's their fault. But you carrying offense of any kind, that's a you problem. Always. Yeah, it happens sometimes. Often, in fact. What do you say, 12? 12 is the one that looks like lots of stuff disappears, cancels, goes away, eats lunch. Oh? Did you figure it out? It wouldn't hurt to do one of these anyway, so 8 times the square root of 3 minus 2 times the square root of 2 times 8 times the square root of 3 plus 2 times the square root of 2. Now, in Algebra 2, I don't necessarily expect you to start really hardcore noticing these things. But I'm going to point this out because we're gonna probably do it the long way. But I do want you to start kind of training your brain to see some of these things in pre-cal and whatever else. These are conjugates, right? What do I mean by that? Something's going to cancel. But what do I mean by their conjugates? What is telling me that vocabulary word equals this? Right. One thing multiplied by the same thing with the middle sign flipped. These are same with the middle sign flipped. And if we multiply conjugates, then normally we do, And we're going to do it the long way, I think, just for extra specialness. Normally, when we do like this, we do FOIL, right? First, outside, inside, last. But when you multiply conjugates, always and forever, in perpetuity, the O and the I will cancel, always. So you can, when you multiply conjugates, just do FOIL instead of FOIL. We'll emphasize that this works. So first, 8 times 8 is what? 64, and then square root of 3 times square root of 3 is what? Square root of 3 squared, which is 3. That's an easy mistake to make, right? That's to accidentally multiply the 3's. But that's all going to cancel and just give us a 3. And then the outside, which is going to cancel in a minute, but just for grins and giggles, 8 times 2 is 16. Square root of 3 times square root of 2 is square root of 6. And the inside, that's going to cancel with this one. Negative 16 times the square root of 6. So see, they're going to cancel. And then negative 2 times 2 is negative 4 times square root of 2 times square root of 2 is 2. True enough. Just like we predicted, these are going to cancel. And then 64 times 3 is 192. I've told y'all this before, but just because it's useful number sense, mental math thing, if you're doing this in your brain, do it backwards. 6 times 3 is 18, so 180. 4 times 3 is 12. 180 plus 12 is 192. Minus 8. And then double check it on the calculator. See, smart. What's 192 minus 8? 184. Blamio. What other questions do we have? 16, yes. Good choice. Conjugates. Excuse me. 16. Six minus the square root of 3 over square root of 3 plus 4. The better you learn how to do this, the easier stuff will be later, because later you might have to do a conjugate with like letters in it. You might even, in fact, you probably will even, if you take pre-cal, have to do it with sines and cosines in it. Oh no. Okay, so what should we do? You did it! Yes, by the conjugate. What would the conjugate be? Minus 4. The numerator's not the conjugate, so we got to do all the FOILs. 6 times the square root of 3 is 6 times the square root of 3, right? And then 6 times negative 4 is negative 24. And then negative square root of 3 times negative square root of 3. What is square root of 3 times square root of 3? 3. And then negative square root of 3 times negative 4 is positive 4 times the square root of 3, because negative times negative turns positive, right? And the denominator, proved and twice proved, all we need is the F and the L. We don't need OI. So, square root of 3 times square root of 3. 3. And then the last 4 times negative 4 is negative 16. So in the numerator, we got all kinds of like terms. The non-square roots, negative 24 minus 3 is negative 27. And then 6 times the square root of 3 plus 4 times the square root of 3 is 10 times the square root of 3 over negative 13. Now, what is the one last question I need to ask myself before I circle this and move on with my life? Can it is the beginning of the question. Y'all are. It can be negative. That's fine. Can it reduce? So does something go into this, that, and the other guy? In this case, no. 13's prime and it doesn't go into those. So it doesn't reduce, so we can circle it. You could, this is equivalent. You don't have to do this, but you could flip all the signs. If you felt better about having a positive in the denominator. These are the same. If you circled either one of these, you'd be right. Because you're essentially multiplying times -1 over -1. And -1 over -1 is +1. You multiply anything times 1, you get the same number. Same. What other questions do we have? We have the square root of 24 times a to the 16th times b to the 8th c. So what should we do?
Figure out what times 2 equals 16 and what times 2 equals 8.
Okay, yeah, dealing with those, that's fine. So the square root of a to the 8th squared times the square root of b to the 4th squared. I'm going to write times the square root of c. Deal with that in a minute. What about the 24? Yes, you can and should.
You find like a square that fits in it?
We should. What perfect square goes into 24? 4. So the square root of 4 times the square root of 6. Now what? What's the square root of 4? 2. So that one's on the outside. These ones are also going to be on the outside, right? So 2a to the 8th, b to the 4th. Do we need absolute values around any of this stuff?
No, because they're positive exponents.
Not positive.
Or
Even. And then the stuff that's left inside is this guy and that guy. Any other questions?
Could you only combine like 3 times square root of 90 if there was another one that was times square root of 90? Like you can't do
Like adding them?
yeah, adding them. Do they
Yeah, although you would reduce the square root of 90.
Oh yeah,
But
you can't combine two that are different.
right. Just in combining, like you can multiply them, but not like combining like terms unless they match. That still wouldn't combine because you'd have like 3 times the square root of 10 of 90, right? So the square root of 10 is not the same as whatever the other one was that you said. All right, kids. Goodbye. Go find somebody that loves you. Give them a high five and a hi, how are you? Or if you prefer, get off my lawn, kids. That'd be fun.